Do you work in healthcare? Do you think that you might be missing something in your digital healthcare landscape? Is your system frustrating you because you think it should do something, but you've been told that it can't? Do you think that there is some untapped potential in your EMR? Hi, I'm John Lee. I'm a practicing emergency physician. I'm also a clinical informaticist and have multiple Epic Analyst certifications. Because of this, I have a unique perspective on how our IT systems and EMRs can work with healthcare. My goal is to spread the word about what we can do with our digital systems, and I've created what I'm calling informatics shorts to highlight how I think we can improve how we use these systems. At this year's HIMSS conference, I was asked to quickly prime the audience for an afternoon of AI. My goal was to demystify artificial intelligence and give an audience of physicians a helpful reference point as they considered using AI tools. I initially thought about the common approach of inundating the audience with definitions and Venn diagrams, but then I realized that this was an easy way to bore the audience. Instead, I centered my talk on 3 quotes to get my points across. The first quote was, "Any sufficiently advanced technology is indistinguishable from magic." This, of course, was the famous quote by Arthur C. Clarke. This sort of magical, sophisticated technology actually already exists in our everyday lives without us even knowing it is there. Maybe one of the most familiar is the predictive keystrokes that are the magic that allows us to use our keyboardless smartphones. For instance, if you type a T, then H, then W, the system will instead substitute E for the W because E is statistically more common in words that start with T and H. Legend has it that this key feature was an element that Steve Jobs fixated on to create what was then the crazy idea of a keyboardless phone. This journey from magical to transparent is actually driven by math. For instance, the T in GPT stands for transformers. Transformers are functions that encode text and phrases into numbers that represent meaning, position, relationships, and context. These numbers are then turned into mathematical matrices and vectors. A function is applied to the matrix vector and yields a result. That result is also a matrix that is then decoded into the next word, summary, picture, or translation. This is definitely an oversimplification, but the key thing to understand is that it's not magic, it's math. Lots and lots of math. And this is why the AI revolution is now here. We have the data that are the numbers to put into the equations. We have the algorithms that are the equations. And we have the computing power that can do the massive amount of computations needed. We have never had all 3 available before. My next quote was, "I know it when I see it." This was actually from Supreme Court Justice Potter Stewart from the Supreme Court case Jacobellis versus Ohio in 1964. This case centered on the definition of obscenity. This is actually the full quote. "I shall not today attempt further to define the kinds of material I understand to be embraced within that shorthand description, and perhaps I could never succeed in intelligibly doing so. But I know it when I see it, and the motion picture involved in this case is not that." The subjective nature of the legal definition of obscenity is similar to the vague definitions we often reference in healthcare. Think about it. How many times has quality, error, and harm rolled off our tongues when we talk about transforming healthcare? Okay, well, how would you define quality? What about error or harm? Would your definition be the same as your colleagues? Would a CEO or CFO have the same definition? Would CMS or an insurance company also have the same definition? It is really important for us as healthcare leaders to be able to describe and define something with data explicitly if we expect to use AI to improve it. Think about it. Does an ICD-10 code or a DRG fully encapsulate all the nuances of the patient you're caring for? Does the CMS definition of a hospital complication line up with what you think is a complication? Remember that AI magic is actually math. To do the math, you need the right numbers. To have the right numbers and equations, you need the right definitions. Too many times we in healthcare manage by knowing it when we see it. We need to be more disciplined and create definitions and data that actually represent what we are looking for. Without these clear definitions, AI systems can and have produced unreliable results, leading you in the wrong direction like a sailor navigating without a compass, or a GPT hallucinating a fact that sounds completely authentic. The final quote I used was, "It's the same stuff we've always done, just faster and more." Okay, I'll admit that I'm the one who actually said this. But to set this up for you, let me start with the example of the heart score. I use it almost every day I work in the ER to document a patient's likelihood to have a heart attack in the next few days. There are 5 factors that constitute the score. History. Does the patient have symptoms that suggest a heart attack? EKG. Does the EKG look like a heart attack? Age. If you're older, you're at higher risk. Risk factors. Things like hypertension, cholesterol, and previous heart disease make you at higher risk. And finally, troponin level. Does this lab value indicate damage to the heart muscle? If the patient had a heart score that is high, that will make us concerned that the patient needs to be hospitalized for urgent testing. But what if that patient with a high score just had a coronary angiogram that showed clear arteries and a note by a cardiologist saying that the patient is not at high risk? These are two additional important data points or parameters that you would include in your decision making. We physicians do this all the time. It is the essence of that frequent comment from radiologists in their reports telling us what they see on the images, but also to use clinical correlation. We shouldn't and don't make decisions based purely on risk scores or a radiology report. We use other data and combine all that information to make better decisions. We use many of these sorts of risk scores in medicine. They commonly have about a half dozen combined parameters that help us make decisions. But EMRs allow us to go beyond half a dozen parameters. Let's look at a sepsis algorithm my informatics team created a few years ago. It goes beyond the half dozen or so parameters in these other tools, but is still a relatively limited number with 33 parameters bound together by a Boolean expression. Now compare this with GPT-1 that had 117 million parameters. GPT-2 had 1.5 billion, GPT-3 had 175 billion, and GPT-4 has in the trillions of parameters. The concept of combining features and parameters is the same as what we already do, but modern data science tools allow us to incorporate parameters many orders of magnitude larger and faster than the traditional half dozen or so that our human brains allowed. AI can be a bit of a mysterious black box, but I hope these 3 points help demystify AI for you. Remember, AI is not magic, it's math. Knowing it when you see it isn't sufficient if you really want to fully leverage AI. Definitions and data quality matter. And AI is similar to what we already do, but it processes far more rapidly and at a massive scale than our human brains. More importantly, I hope thinking of AI in these terms helps you make better decisions as you form your strategy to incorporate AI technologies. Thanks for watching. If you want to learn more about who I am and what I can do to help you with your health IT, Epic, or analytics efforts, drop me a line and let's talk.